In this video, we will learn how to differentiate using first principle method, how to find turning points, and how to find equation of normal. Hello everyone and welcome to Mathematics, where this channel is able to help you to build up your habit in completing a question a day in mathematics. So for today's video, we will look at a question from Form 5 Chapter 2, Differentiation. So before we begin, you can take a look and try it by yourself first. So for part A, what we can highlight is these two. So what is gradient function? It's actually dy over dx. So let's say if I were to find the line which passes through this point, which is a tangent, I can find its gradient using dy over dx. So it's also considered one of the gradients. And the first principle method means that we need to use the original way of differentiation to find dy dx. It's not the one that we use all the time, which is, let's say, 3x squared. If you want to differentiate, we just multiply the 3 and the 2 to get 6 and power minus 1. So it's not this case. We need to use the original differentiation way. So later I will introduce a 4-step method for this. So step number 1, we just need to add a delta x for each x in the equation and delta y for each y. So it will look something like this. So each y has added a delta y, and for each x we added a delta x. So delta is this symbol. And we will simplify this equation. So step number 2, which is to change our y. So this y, we need to substitute the original equation, which is 3x squared minus 6x plus 5. So you may notice those are in red also appear on the right side as well. So here we can actually cross off each other. So the 3x squares, the negative 6x, and the plus 5. So this will be the simplified version. And step number 3, we need to divide the whole equation with delta x. This will be the simplified version. And finally, we need to add a limit whereby delta x approaches to 0 to both of the sides. Since this thing will approach to 0, meaning it will become 0. So 3 times 0 will be 0. So the whole thing here will disappear. So your final answer will be 6x minus 6. So we can double check 6x minus 6 using the shortcut way of differentiation with this equation. So let's check. So if differentiating 3x squared, we need to multiply the number and the power, and power minus 1. And here we just pull the number. Plus 5 we can just ignore. So it's the same with our answer. Alright, so moving on to part B, we are finding the coordinates of the turning point. So this involves the second application in differentiation. So what turning point means is there are actually two types. One is the minimum point and one is the maximum point. And to find out turning points, we can actually use dy over dx equals to 0. So why does minimum and maximum considered as turning point? So by looking at minimum point as the example, you can see that the curve moves downwards in the beginning, but after going through the minimum point, it goes back up. So it changes the course of the curve. That's why it is called a turning point. And why is it dy dx equals to 0? It's because if I were to draw a tangent through this point, you can see that it is a horizontal line. So as we know, horizontal line is always m equals to 0. Its gradient is 0. That's why we can use dy over dx equals to 0 to find our turning point. So here we can just use back the answer that we got from part A and sub it into dy over dx. And our x would be 1. So because we are trying to find the coordinates, so we can use back the y equation and sub 1 to get our y coordinate. So our coordinates will be 1, 2. And lastly, the third part is we need to find the equation of normal using this point. So this actually involves the first application of differentiation. So what does the equation of normal mean? So let's say we have a tangent through this point. Normal is actually perpendicular to this tangent. Now we are trying to find the equation of normal. So to find this equation, make sure we have these two things, gradient and a point on the line. So here our point can be 2, 5. But for gradient, we can depend on this tangent's gradient to help us find the normal's gradient. Because for tangent's gradient, we can calculate using dy over dx. So by subbing in 2 into dy over dx, so the tangent's gradient is now 6. And since they are perpendicular to each other, we can use a formula from Form 4 Chapter 7, which is multiplying the gradients of the perpendicular lines, you will get negative 1. So here, subbing 6 into m1, m2 we will get negative 1 over 6. So now we can use y equals mx plus c to form our equation using these two informations. And finally, our equation would be this. Right? So we have completed this question. So before we go to the take-home points, I have to apologize that this one should be delta y over delta x. And teacher would like to explain why the limit delta x approaching to 0 for delta y divided by delta x is actually dy dx. So I'll use the example on the left to help you all understand. So for the x-axis is the time, and the y-axis can be any quantity, let's say the number of bacteria or number of computers and so on. So for this curve, this means that when time goes by, the quantity increase. So now let's say I want to find how fast does the quantity change during this point. So here we can use the gradient to help us out. But remember, during modern maths, if we want to find the gradient, we need 2 points first and use the formula to help us out. But now we only have 1 point and the line is a curve. So one of the solutions is we can choose a point which is very close to the point that we want. Okay, so let's zoom into this area. So we can actually use the same way to find the gradient or to find our speed. So y1 minus y2 actually calculates the length here, and we can actually express it in another way, which is delta y. It's because we are finding the differences of both y coordinates, and the value will be very small because they are close to each other. And for x1 minus x2, also the same thing. Let's rename it as delta x. But there is an issue because now it is a curve. It will not be the exact correct gradient for this point. So what we do is we try to minimize this delta x, which means this point will go more closer to the point that we want. So that's why we need to add a limit where delta x approaches to 0, because we want to minimize this and to minimize our delta y to find the correct or accurate gradient. So that's why when finding gradient of a tangent, we need to use this expression. But this expression is too lengthy, so they rename it as dy over dx to simplify things. Alright, so let's go through the take-home points. The first one would be finding dy dx using first principle method. So these are the 4 ways that we have gone through just now. The second point would be when finding turning points, make sure to use dy over dx equals to 0. And lastly, in part C, we found out that gradient of tangent is actually dy dx. And gradient of normal, we can actually use m equals to minus 1 over dy dx. Because by multiplying these two gradients together, we can actually get negative 1, which is what we learned in Form 4 Chapter 7. If it's negative 1, which means it's perpendicular. So if you are interested in this question's answer scheme, you can click the link in the video description, and you feel this is beneficial to you, please give a like, subscribe, and share it to your friends and classmates. And if you have any questions, feel free to comment below. So I'll see you all very soon in the next video. Thank you.